Hello chemistry students. So here's the second part of the significant figures video. So what I'm going to do is I'm going to show you how to do mathematical operations and round to the correct number of significant figures. If I didn't emphasize that enough in the last video. Significant figures basically is just all about knowing where to round so that you reasonably represent how well you know the numerical answer to a problem. And I will say here, if you think the rules are odd for significant figures, well, maybe. But I've done what's known as a rigorous error analysis, sometimes involving calculus in some of my upper level chemistry classes. And one of the things that I found quite remarkable was how doggone close the significant figures rules got you to having the right number of digits for whatever uncertainty accompanied your experiment. And I will say that as complicated as you may feel like significant figures are, they are not as complicated as doing a rigorous error analysis with calculus. So anyways, with all that said, here's how we add, or actually let's do multiply and divide first. So for multiplying and dividing, the number of significant figures in the result is going to be equal to the number of significant figures in the least precise measurement used in the calculation. So for example, if we do 6.38 times 2.0, you would get a calculator answer of 12.76, but you would round that to two significant figures, so 13, because the two numbers involved in this calculation, 6.38 and 2.0, 6.38 has three significant figures, 2.0 has two significant figures. Remember, trailing zeros are significant when there's a decimal point expressed. So you round off. And just like when you're at, like I keep the first significant figure, I keep the second significant figure, I look at the next digit, it tells me to round up because it's greater than 5. 5 or greater, let's say that. 5 or greater, you round the previous digit up. Okay, so this is rounding. You've done rounding before. It's just a more advanced way to pick the place where you should round instead of asking the teacher, hey, how many decimal places? Okay, now we're doing something more sophisticated, significant figures. Alright, so let's do some practice here. I would recommend that you maybe pause these or maybe even plug them into your calculator and give them a try yourself. Alright, so here's 3.24 times 7. Calculator says 22.68. The answer you should give, three significant figures here, 2 here, so the answer is going to be limited to 2 significant figures. So we're going to round we're going to round the second significant figure. Check the next digit there, and it's a 6, so that's going to tell us to round that 2 up to an 8. The answer is 23 meters squared. Alright, this one we're going to divide. So the calculator gives you this answer. Certainly we don't know this to out to the nanoscale, so we don't need to report all those digits. How many should we report? Well, the decimal point is expressed, so all the trailing zeros are significant. That's 4. This one has 3, so the answer, well, 4, 3 is the smallest number, so we should have 3 significant figures. So 1, 2, 3. Look at the next digit. It's greater than 5, or is 5 or greater, so we round up. So 4.22 grams per centimeter cubed. Alright, so calculator here says this, but let's see, we have one significant figure here. Remember, leading zeros are never significant. And that has 4. So yeah, one significant figure. I'm going to round to one significant figure. So 0, 0. Okay, here's the first significant figure. Look to the next digit. It is 5 or greater, so I'm going to round that up. So 0.05 centimeters cubed. And remember, those leading zeros are not significant. So this does only have one significant figure, just like that one did. All right, 710 divided by 3.0. Calculator says this. Certainly too many digits there. So, two significant figures here. That trailing zero is not significant because there is not a decimal point expressed. And there are two significant figures here because there is a trailing zero and there's a decimal point expressed. So our answer will be limited to two significant figures. So 2 and the 3, look to the next digit, it tells me to round the 3 up to a 4. So 240. Now, something that I've noticed from students in the past is that there's a great temptation here to round this to 24. Now, if somebody tells you, I'm going to give you $236, and then they look in their pocket and they're like, I've only got 20s, how about 240? I'd take that, that's fine. It's the same order of magnitude or the same size number. You got to have that zero in there as a placeholder, even though it's not significant. But if somebody says, I'm just going to give you $24, that's not the same size number. It might have the right number of significant figures, but it's still wrong. So make sure when you're rounding, you do put your placeholder zeros back in there. We want to maintain the value of the number. All right, this one, 5 significant figures, 3 significant figures. The answer should have 3, 5, 8, 7. Throw your placeholder in there, and there you go. That 2 does not round the 7 up, so there you go. All right, 4, 3. Answer should have 3 significant figures. 3, 5, 8, round up, so 0.359. All right. All right, so when you add or subtract, the number with the largest last significant place limits the number of significant places in the result to that same place. Now that is a mouthful of a statement. So let's look at some examples. This one, 6.8 plus 11.934. So when you add those together, this number is significant to the tens place, or the tenths place, whereas this number is significant to the thousandths place. And the thing that's important for you to realize here in the significant figures world is that the last digit is an estimate. So when we say 6.8, we're really just kind of like, we think it's between 6.7 and 6.9. So that means we have no clue what's going on out in the thousandths place on this measurement. If we did, we would write those digits down. So I know in your calculator it just assumes, well, there's zeros out there. But in the real world, we don't know what's out there. So everything after the tenths place is uncertain. So that means when you add these numbers together, everything after the tenths place is still uncertain. So the answer should be only reported to the tenths place. So notice that, this is not the same rule as multiplying and dividing, because if it's the same rule, we would round to 2 significant figures. But no, we look at significant places in the number, and whichever has the largest significant place, like tenths place is larger than the thousandths place. So, and it's the last significant place. So there you go. All right, let's look at another example, 170 plus 18. So this is significant to the tens place. Remember that 0 is not significant. And this is significant to the ones place. So our answer should be rounded to the tens place. So you get 188 as a calculator answer there, and then we're going to round that to the tens place and make sure we put our placeholder 0 in there. All right, here's some examples. See the largest last significant place. This one goes out to the hundredths. This goes to the tenths. So we're going to be limited to the tenths place. So 10.2, 4 does not round the 2 up. So there you go. All right. 100 minus 23.73, tenths place, hundredths place. So we're going to be limited to the tenths place. So 76.2, the 7 will round up the 2. All right. Significant to the hundredths place, significant to the thousandths place. We're going to be limited to the hundredths place because it is the largest last significant place. All right, and there you go. And then we're going to round to the hundredths place. All right, and again, not the same rule as multiplying and dividing, because if it was, we would only have one significant figure, but we have 3 because when we add and subtract, we look at the largest last significant place. All right, here's another one. Tenths place, thousandths place. We're going to round to the tenths place. And that's going to be 709.2 liters. All right. Tenths place, hundredths place. We're going to round to the tenths place. There you go. And one last one. Thousandths place, thousandths place. The calculator says that, but we're supposed to go out to so put the 0 out there. That 0 is significant because it's trailing and the decimal point is expressed. So when you write that down in chemistry, at least, you're saying, hey, I'm pretty sure that that's actually what that measures exactly. All right, and that is all for significant figures. So thanks for watching. Hope you found this helpful, and feel free to go back and rewatch or ask me questions if you're having struggles with significant figures, because a lot of people do, but this is a better way to round.